Thank you. Good afternoon. Thank you. Good afternoon, everyone. I'm Rachel Kraft with NASA's Office of Communications. Engineers completed a cryogenic demonstration test on Wednesday ahead of the next launch attempt for the Artemis I mission. Artemis I is a flight test to launch NASA's Space Launch System rocket and send an uncrewed Orion spacecraft around the moon and thoroughly test the spacecraft systems before missions with crew. We have several folks here today to talk about the recent test and provide an update on current activities. They are Tom Whitmire, Deputy Associate Administrator for Common Exploration Systems Development at NASA headquarters, John Blevins, Chief Engineer for the Space Launch System from NASA's Marshall Space Flight Center, Brad McCain, Vice President and General Manager for Jacobs Space Operations Group, and we also have Mike Bolger, Exploration Ground Systems Program Manager from NASA Kennedy. We will have a few opening remarks from each of our speakers, and then we'll take some questions. Reporters can enter *1 on your phone to be entered in the question queue at any time. I do want to also note that teams are keeping a close eye on the weather, and we do also have Mark Berger, Weather Officer with Space Launch Delta 45 here to answer any questions about the weather forecast after our opening remarks. And with that, we'll start with Tom.
Okay, thank you, Catherine. Yeah, we're excited to be here today. There's a lot of things going on. I was privileged enough to be here at Kennedy Space Center for the cryo demonstration test on Wednesday, and it was very interesting. I think we learned a lot. We accomplished all our primary objectives for the cryo demonstration test. We were able to look at the loading operations. We made a tweak in that, and I think we were successful after that. We did the kickstart. We did the pre-press, and we did a chill down, a stable replenish. And then during all those events, we actually monitored the vehicle and adjusted a few parameters, and that was all actually very successful. So we're excited about that. We have some good experts here. Of course, Dr. Blevins, as you all know, is going to talk a little bit about that. And I just want to make sure people understand Brad McCain. I've known Brad for a little while now. How many shuttle program loading operations did you do, Brad?
Yeah, I did 108 of the 135 shuttle missions, but close to 200 tankings. Cryogenics is where I started.
Yeah, so Brad's our kind of cryogenic expert. He's here to kind of keep us straight and work with John to provide you information. And then Mike Bolger is going to talk a little bit about where we are on the weather. We take this a step at a time. We have to watch weather and incrementally make decisions as we go along. We'll watch the direction, the intensity, and the timing of the weather pattern. We'll make the decisions when we make the decisions. So Mike will talk a little bit about that. But overall, we feel that we really got some great data from the test. We accomplished what we were hoping to accomplish. You saw Charlie talk about it afterwards. We were pretty excited with the information we got from the test. And with that, I'm going to talk it over to Dr. Blevins. He's going to talk to you too about it for a second.
Hey, good afternoon, everyone. Thanks for your interest in the rocket. I will report, as Tom said, that we had a very successful tanking test. All of the tanks of the vehicle, all four, fully topped off. We were able to do some things that we won't have to do again, dial in some things that we intended to do even on launch day that were left over from previous wet dress rehearsals. So it was a very successful day. I think all the secondary objectives were actually met, not just the primary objectives. And so it was a really successful tanking test. So I'm glad that we were able to fit that in on Wednesday with weather and everything. Also, the vehicle's looking good. The vehicle's ready for launch attempts coming up. We continue to look at life-limited items. We continue with high-definition cameras to scan over the vehicle to make sure that everything looks good, any of the TPS and all that. We also continue to do walk downs and just prepare the vehicle for the flight ahead. With that, I'm going to pass it to Brad McCain. As Tom said, he's not just a VP, he's a cryo expert, and so he's here to handle your tanking questions, but really glad to have his expertise the other day in the tanking test. Brad?
Thanks, John, and again, I'm glad to be here to talk about the cryo test as well. It's I never get tired of talking about cryogenics, and they probably get tired of me talking about cryogenics. But again, between the second launch attempt and the tanking test we did on Wednesday, I think that do want to compliment the team on doing a great job of making the necessary adjustments out in the field, as well as the executing the plan that I think Charlie and everyone had laid out in the last press conference as far as what we were going to do from a repair standpoint on the seals, as well as especially from the cryogenic team perspective, the procedure updates and the software updates we were going to do to try and, I think you've heard the term, the kinder, gentler loading approach this time around. And I'll tell you that the term and what that means. So it's, from my perspective, you know, having done a lot of loadings back on a different program, but they're all the same, whether it's Apollo, Saturn, or PECO commercial provider. Cryogenics is a very difficult propellant to try to handle. It's very complex, and the one thing that cryogenic operations like is repetition. We like to do the same thing the same way each and every time, and it's hard to do on the first mission of the first program of the first vehicle of its kind. And in this particular case, you know, we have testing done at KSC over at the LETF facility, verifying hardware, and testing done at Stennis, which is a different configuration than the final hardware that we're here at Kinney from a ground infrastructure perspective. So what we're trying to do is mesh all that together and find the right optimum efficiency of the hardware, the right fine-tuning, if you want to look at it that way, of procedurally how to load the vehicle. And so when you do that, you learn a lot of things, and we're constantly learning on this vehicle the right approach, the right requirements. You do analysis and you do con-ops, and you try to figure out the best approach to loading this vehicle and the best way to go about that, and then you do it and you learn. And that's what you're seeing here is that learning curve. And I think this last tanking test on Wednesday, we learned, and again, we've come up with yet a kinder, more gentler approach. You know, the thermally, pressure-wise, these are things that the cryogenic systems you learn to deal with. All these things we're seeing, they're not unfamiliar to anyone that's worked a cryogenic system. These are things you deal with. 135 shuttle missions, every one of them had cryogenic leaks of some sort that you dealt with sometime during the flow. Every one of them had issues like these, and you work around them, and you learn to deal with them, and eventually it's all accounted for in your procedures and your software. And so we'll be getting there with this vehicle as well. So I want to compliment the team on doing a great job. We went in with a plan, as you heard if you were monitoring there, when we went into the transfer line showdown, we on the LH2 side went in with a lower storage tank pressure, trying to minimize the pressure and thermally shock in a slower flow rate. Did encounter a leak there. Worked our pre-planning contingency to go in and isolate that QD, warm it up again, which is what we had done on the previous weight dress rehearsal and launch attempt. I went ahead and took that scenario and went ahead and lowered the storage tank pressure in the storage area again to the lowest 5 psi in the storage tank that we're keeping track, and came back again and did an even lower flow rate and came back up again and saw better results there. As we went back into fill and recovered to fast fill, we did see the leak start to respond in a different manner. As John noted, we went ahead and did the kickstart when we got into fast fill. That was successful. At that point, the pressurization, you did see a decrease in leakage. As storage tank pressure increased, we went from 5 psi in increments of 5 up to 45 psi in the storage area, and the leak started decreasing down to a minimum rate of, I think, 0.6% by the time we got close to real planners. So and John can talk to you more about the pressure sealing aspect of the seal itself, of the QD itself, but as more pressure was applied, we did see the leakage decrease and to allow us to finish the rest of the test objectives. So all in all the test objectives were satisfied. Again, the loading procedure, I think, we're very comfortable with. It's very repeatable going into the next launch attempt on Tuesday. Very minimal procedural changes will be required, and I think the team feels very, very confident that we'll have repeatable results here. And again, cryogenic systems like repetition, and that's what we'll have on Tuesday.
Okay, and I do, Brad, thank you. I do want to pause here. I think we are having a little bit of technical difficulty on streaming this to nasa.gov/live. So if we can pause for a minute here while we troubleshoot, we'll then pick up with Mike Bolger. So give us a second here.
Okay, hey,
okay, thank you. Go right ahead, Tom. I think we'll let you start us off again. We won't repeat everything we said because I do know we are recording this and we'll have the replay available. But understand that our feed on nasa.gov cut out around the time that Brad McCain was getting started with his remarks. So we'll repeat a little bit of that. Go ahead, Tom.
Okay, and Brad did a great job. So the folks that heard it, you had a pretty good discussion from Brad. For the folks that didn't hear it, we'll have it later for you. So, Brad, you can go ahead and do the 2-minute version. I thought you did a great job the first time. So, and then we'll get to Mike.
Okay, thank you, Tom. So, again, just wanted to compliment the team on doing a great job of making the necessary procedures and software adjustments required to get into the tanking test on Wednesday. I do want to reiterate the point that from a cryogenic systems perspective, repetition is what we'd like to see. We want to do the same procedure the same way on the same hardware multiple times, and that way you can trend the systems. That's how you learn the hardware, learn the system, and get repeatable results. So first time vehicle, first time launch. In this case, we're trying to integrate testing we had done at LETF with testing done at Stennis from a loading perspective to our infrastructure down here at KSC. And so some of the growing pains you see and how we learn the hardware and the efficiencies that we're trying to gain here from a loading con-op perspective are really what you would see on any first-time program. I've got a lot of experience in cryogenic operations, and it's not something that's a surprise to me. And there are things that you likely would expect if you've done this kind of work before. So we keep learning. We've made a lot of progress. I'm optimistic about our procedures and our ability to repeat what we've done. We did on Wednesday. So what we did on Wednesday, real quick, is you heard the term kindler and gentler loading, I think, from the last press conference, and that's basically what we did. And what that meant is we just extended some timers in our LH2 storage area in order to slow down the flow rates, gravity feed, or pressure gases into the transfer line in order to more slowly chill down the mass in order to not thermally shock the piping and by indirect effect the seals eventually, in order to get a more gradual chill down of that piping and more gradual or less effect of the pressure on the lines. In order to do that, to less dramatically affect the hardware, so the dynamics are less, and hopefully you get less dynamic effect on the seal. So we did that. We did encounter a leak early on, and operated and did our pre-planned contingency procedure. That came back and continued with that testing. Went ahead and lowered our storage tank pressure, which had an even kindler, gentler approach, down to about 5 psi. Recovered it to a slow fill operation, and went ahead and saw acceptable results. The leak got better as we completed our kickstart, which John had talked about earlier. And as we got into fast fill and ultimately replenished operations, the leak basically went down to very low, 0.3% reading. So, and proceeded the rest of our tanking test objectives. So, all in all, it was a great day. Very happy with the results. Very optimistic about our next launch attempt on Tuesday, and the team's ready to proceed.
Okay, this is Mike Bolger. I was in the firing room Wednesday as well. I remember after the test, one of the most senior cryo folks was talking, and I'm going to repeat what he said to me. He said, if we can tank the vehicle, we can launch the vehicle. And on Wednesday, we proved we can tank the vehicle. And so, big deal for us, really good day for us. by Wednesday night, we started turning our attention to moving forward towards that launch, and we realized one of the things that we're going to have to pay attention to is the weather. So since then, we've been keeping a close eye on what's now called Tropical Depression number 9. Given the uncertainty in the storm track, the uncertainty in the intensity and the arrival time, our general strategy is to buy some time to see if we can get better convergence of the models and use the models and then use that data to inform a decision. So our plan A is to stay the course and to get a launch off on September 27th, but we realize we also need to be really paying attention and thinking about a plan B. If we were to go down a plan B, we need a couple days to pivot from our current tanking test or launch configuration to execute a rollback and get back into the protection of the AB. So we are looking at each of the weather forecasts, each of the model updates as they come out. We're going to meet again tonight after the 5 o'clock models come out, talk more about it, and we think we're likely to make a decision no later than sometime tomorrow morning or very early afternoon. Kind of big picture, the numbers that we're looking at from a launch standpoint, we're good at the pad for winds up to 74 peak knots, and for rollback, we're looking for a forecast of sustained winds less than 40 knots. So those are kind of big picture, the things that we're going to be paying attention to. We'll be keeping a close eye on it. More information is better, and like I said, I think in the next 24 hours or so, hopefully we'll get good news, and we'll stick with our plan A, which is to get a launch off here on the 27th.
Okay, thank you. We'll now take questions from those who have dialed in on the phone. Just a reminder to our reporters here that you can press *1 to be entered into the queue. And please state your name, affiliation, and to whom you're addressing your question. And with that, we'll get started with our first question from Marcia Dunn.
Hi, yes. So it sounds like if you were just basing everything on the results of Wednesday's fueling test, you would make a go for Tuesday. And how would you deal with any leaks that might come up and stall the whole, the countdown? I mean, it seems like that would take time to sort through all that. And when is the last possible moment? How late can you actually wait before deciding whether to roll back? I think you said sort of by tomorrow afternoon. I mean, is that the deadline for deciding what to do? Thanks.
You see, Marcia had 2, so let's go for the first one. First one is how do we deal with leaks if they come up again? And so, John, we'll start with you on that one.
Yeah, just a short answer is, the machine learning that Brad talked about, right, the 2 systems. One of the things that we did do is we learned how that seal works and how it handles with pressure, and it very well could be that some of the previous procedures we had where we would stop when we detected a very small leak, the beginning of a leak, if you will, in the environment we had, we would stop and basically isolate the system. That turned out not to be the right, goal. And so what we did this last time, and Brad can give a little more details, we just stair-stepped the pressure, and we were able to accommodate that seal process very well. And I think when we replicate that, we'll find that we get the same results. But if it does leak, as Brad mentioned, we have pre-planned contingencies. We have lots of parameters that we were able to use over the time, and I think we're back in the box of understanding what we did at the LATF, the Launch Equipment Test Facility, on the vehicle. And so time is always an issue in a launch countdown, but I think we're going to try to accommodate that. I think Charlie's working to address that. Brad, do you have anything to add there?
No, I echo what you said, John. The pre-plan that we worked on Wednesday was exactly what we did at the LATF and got the exact same results. Let the valve warm up, activated the drain assist purge, so warmed up for 30 minutes and recovered. We do now know that the lowering the storage tank pressure, we can control the storage tank in the storage area at that 5 psi and meet all the other requirements just from a loading perspective. So we demonstrated that on Wednesday. So now that we know that we can do that, then that's another acceptable way to control the loading. So.
Yeah, it's kind of Marcia, Tom. It was really cool to watch this real time because we have all these parameters up in the screens and we look at them, and they would do a little more pressure. You could see what was going on with the seal. So, you know, the predictability is really being able to watch it in a repeatable manner and see it provide a consistent kind of response back to you. And we were able to observe that, and that's like a really big deal for us. It gives us a chance to figure out how to, I don't know what they call it, Brad Baby the seal through the transition to fast fill or.
Yeah, I mean, you're coaching it if you want to look at it that way, but it's really just again, it's all down to trending. And, you adjust the pressure you expect to see when you see it behave in the way that it should. Then it gives you the confidence that you're on the right track and hardware is behaving the way it's designed to, and it did. So
the kind of gentler pressurization helps us with the coaching, and now we're getting better at coaching the seal, so that's a good place to be.
Yep.
Okay, Mike, I think you got the second one, and as a reminder, weather is it's not even a named storm. It's a tropical depression number 9. It's very early in it, and some of the traces we've seen go to different directions and go at different speeds and have different intensity. So I think you said it again, we kind of take it a step at a time.
Yeah, thanks for the lead in, Tom. You know, I think the question was, give me a drop-dead time, and really we can't do that because of the uncertainty of the track and the arrival time. The things that we're paying attention to is, you know, if the track shows it's coming towards us, what would be the arrival time of tropical storm force winds, and we're doing that because that really would kind of inform the decision that we would make if we wanted to roll back. Because like I said, our rollback criteria is winds less than 40 knots. So we're generally keeping track of that, and if our decision were to be to roll back, we want to be a couple days in front of that. However, you know, again, our plan A is to stay out there. We're going to be monitoring the data as it comes in. You know, we tentatively we're looking at a decision no later than, I said, tomorrow morning or early afternoon, but it's very dependent on how the storm changes over time. It changed quite a bit from Wednesday to Thursday to Friday, and that could happen again tomorrow, or over the rest of today and tomorrow morning. So it really is hard to point a precise time, but certainly I think, you know, tomorrow, no later than tomorrow.
Okay, our next question is from Bill Harwood of CBS News.
Hey, thanks very much, guys. I think this is for John Blevins. You know, looking back over this, it's 190 days, believe it or not, since the initial rollout. And it just seems like there's been ongoing problems with leakage, you know, in LH2QDs or seals. And I'm wondering, why is it okay to manage those mechanisms by juggling pressures and flow rates and such when it doesn't seem like they're performing as they were designed? I mean, you don't design them to leak, right? And so, you know, you mentioned repeatable phenomenon. I mean, didn't the warm-up technique not work when you tried it during the second launch try? I'm not understanding this, and I'm hoping you can maybe shed a little more light to help me understand it. Thanks.
Yeah, hey, thanks, Bill. Any new system's going to take a while. I think that's not, you know, too different, whether it's an aircraft or anything else. On this one, you know, I will go ahead and say that, you know, we've got a fault tree for what happened in Launch Attempt 2, and we've got some signatures that are actually different than what we expected. And so I don't want to get into detail there because we don't know exactly what happened. We have mitigated things down the fault tree. I think, you know, the comments, just to distill down some of what Brad added too, is that, you know, the pressure and temperature of that seal, any seal in cryogenics is always going to be tricky, and we're trying to get in that operating box, right? And so I'm going to give you an analogy that's more dear to me, I guess, propulsion. You know, when they started the Space Shuttle main engines, it took them a long time to get that start sequence right. We don't question that start sequence today. It took them 18 months to get that start sequence. And so I'm just pointing out that when you learn machinery, sometimes it takes a while to find out the stability points, and that includes that seal. When we designed it, and we do understand that design generally, and then we took it to LETF, the Launch Environments Test Facility is actually that art of partial modeling, and it's what you want to do, right? You can set up a facility that's smaller, it's less expensive, takes less operation, so you can map out things. Well, some of the things that are different, since that's the art of partial modeling, is that you don't have the largest hydrogen cryogenic sphere around, right? And so when you go to those bigger systems, it's some of those things that may inform you that you didn't know everything you might have thought you know about the seal, and that's what we experienced. We knew there was risk. That's why you do a wet dress rehearsal, and we did get through the wet dress rehearsal. We did see some leakage there, and those data also play into the decisions that we made. And so I'm not really discouraged, if that's the question, just because, as I mentioned on the SSME, I like that analogy. There's no question we know how to start that engine. But when you started working to start that engine and to get all of those things right back on the first test stand with a single engine back in the 1980s, it took more than 18 months to figure out that sequence to perfect it. I believe that we're heading toward perfecting a sequence. It'll take some launches to get that perfected. I'm not saying we won't have additional concerns or leaks. We're learning the machine, and this is the first launch. What I am saying is it's a machine. It's bounded by physics. And as long as we work to understand those parameters, when we replicate those parameters, we should expect that machine within its life to operate the same way every time. And that's going to be the premise we work on, and that's how we're going to solve that issue.
Brad, did you have any other thoughts on that?
Along the same lines, thinking of the storage area and the storage tank, I got 1,200 feet across country line, 10 inches in diameter, vacuum jacketed, and I've got valves in the storage area that are open and closed valves. So I've got at Stennis, I've got modular valves that I can position 20, 40, 60, 80, 100%. So there's more control at Stennis, smaller volumes, as John mentioned, at LATF. And I got, you can look at it as screwed. It just wasn't designed to be a test facility. It's an operating facility there. So I'm trying to use large components to control pressure and temperature there. So as I learned that for this application in this seal, that maybe it's not working that great. So now I'm using a 850,000 gallon storage tank and a pressurization to try and dial that back some for the cryogenic loading approach. And so yeah, as you said, we're figuring out for this particular application what's the best way to load it, and it does take time. I got again another analogy, but at least different program, same commodity from a cryogenic perspective. For the LOX loading system, SDS7, I believe. So it took I want to say 8 or 9 loadings, but through SDS7 before we finally got down the loading procedure that we used to load the liquid oxygen system. So it took a lot, and we did change it, I think, probably over 100 times over 25 years. So it never stayed the same, even though the hardware never changed, really. So you make tweaks and things throughout the life of the program, but it took a lot of tankings early on to get it right, to get it consistent and get it to where we wanted it.
Yeah, I guess, Tom, I would only add, if you look at other programs, other vehicles, they go through a lot of that. We tend to be doing it more publicly than most, but I assure you all launch vehicles have these type of dialing in moments, and we're dialing it in. I look at all the pieces of the puzzle that have been put together at this point. The LOX loading operations going very well. Hydrogen, we just had to get to this last piece of the puzzle, which was the transition to fast fill. I think there's been a lot of progress made, and it's very consistent with our launch systems and our experiences during the shuttle program. I think I can imagine if you're not directly involved in it, it'll seem frustrating at times. For us, we're actually very encouraged by the cryo test, and so we feel like that was a good accomplishment.
Thank you. Our next question is from Chris Davenport with the Washington Post.
Hi, thanks so much. I just wonder if you're maybe cutting it a little close with the weather coming. I know we're a few days out, but you also said you want to stay a couple days ahead of that wind. It's going to take you some time to get it back. So I wonder, as you press ahead with Plan A, the launch on Tuesday, if there's anything you could do simultaneously to work on Plan B to roll it back, and if that's something you're doing just so that you could do that expeditiously if you needed to. Thanks.
Yeah, we have asked the test team to look at exactly that. What are the things that we could do that basically would move the ball forward, whether it's Plan A or Plan B? So maybe something like retract the crew access arm would be an example of something like that. Well, at the same time, like you said, keeping a close eye on, exactly what are the things that we need to be doing. So from another thing that we take a look at is, what are all the things we would do as a part of our rollback preps, and so we start to look at getting umbilical arms in the roll configuration. We've got a lot of heavy metal that we would potentially move. We got side flame deflectors that we could retract and remove extensible columns. Those are the things we're taking a look at. Right now, we're more in the phase of cataloging the steps that we would take and looking for those things that in parallel move the ball forward. But at the same time, we are kind of looking at steps that would move the ball forward in both paths.
Yeah, we'll talk again tonight and see how the weather's going. Remember, it's changed dramatically over the last few days. So we went through this all the time with the shuttle program. We have a step-by-step measured approach for looking at the weather, seeing which direction it's going. I think the team has taken all the necessary steps. We have pre-planned, activities associated with rollback. We had this planned a long time ago. And so we'll just, I don't think we're cutting it close. I think we're cutting it just at the right time. If you cut it too early, you really regret the day that it turns up and goes up the Gulf. And if you wait too late, I think we're just really actually going to be fine. We will monitor it. We'll have another conversation today here in exactly 4.5 hours, and we'll take another look at it. And we'll just, unfortunately, at this stage in the game, most people will tell you we'll talk weather a little bit later on. It's just almost not at the point where we can absolutely predict what direction this is going to go. And that's what we wanted to try to get a little bit more information to be able to do that.
Okay, thank you. Our next question is from Kenneth Chang with the New York Times. Okay, Kenneth, I don't think we can hear you. If you want to start again.
Oops.
I think we got you.
Can you hear me now?
Yes.
I was just asking, what's the distinction between the hydrogen kickstart and the pre-press? In the past, it seemed like those were used interchangeably. It's the one thing that was missed during the wet dress. And in the past, in this tanking test, there were two different tests at different times. Thank you.
Hey, this is John Blevins. I think, Kenneth, it was a little bit garbled. I think what you asked was about the relationship between the kickstart and the pre-press and the timing. They do perform different functions for us, and not to be confused, the pre-press being early in the launch attempts that we just most recently done was an artifact that we didn't dial in what we expect in terminal count, right, when we get ready to launch and making sure we hit the right start box. So that is normally late into our count. It certainly has to be done after we're full, but it's normally very late into the count. And so some objectives were reached in this particular tanking that allow that to fall into the correct timeline that we've always wanted it to be later in there. And so that's really about hitting the conditions, that pre-press, right before we get ready to launch and take off. So the kickstart really is about the fact that we've got multiple engines and we've got multiple friction, if you will, flow paths. And that can be just based on just how it's the sun's setting that day, if you will, or whatever. And so we want to make sure we've got good liquid flow to start the chill process. We've talked about the chill before through that. And so that's a very lower pressure situation. It's not going to flight pressure. And so that kickstart does start earlier just to get that flow so that we can just start our chilling of the engines correctly and make sure that we've got the right flow through all of them. And that's what you saw in the launch attempt one was our inability to understand some of the sensors, and we've talked about that. So they do not exclusively need to be together or in the same point in the timeline that they've been before. They have specific objectives, and we can move those around to make sure, but we have specific criteria for how long we chill the engines and specific start box requirements for when we do the pre-press. And so we met all of those extremely well in this tanking test. So let me just go back to these primary and secondary objectives of this tanking test. There's not an objective that we had that day that we did not achieve in spades. We really have those valves dialed in for the pre-press. And for the kickstart, we saw exactly the instrumentation we want. We've gone back and looked at the supplemental instrumentation that we figured out, give us a witness on the chilling and the flow process. And it's, as we've stated before, once you've got a machine and you replicate processes, you see the same result. And that's what we have. So will we move those around? We're looking at when to move those around to fit things in the timeline, because we always will, in order to preserve the best timeline we can. And that's up to Charlie, and she looks at all those requirements. But they don't exclusively have to have a time length. There's not an iron bar, so to speak, in time between them. They have different functions. You will not see a pre-press until right before we get ready to launch, because that's the whole point of the pre-press. We just did that on the other launch attempts to clean up some things that we wanted to make sure we didn't get wrong very close to launch. So good question. Thank you, Kenneth.
Thank you. Our next question is from Micah Maidenberg with the Wall Street Journal.
Hi there. Excuse me. Apologies if I missed this. What's the status with the waiver package with the range regarding the flight termination system? Has that been resolved, or is it still outstanding? Thanks.
Dr. Blevins, I think we'll let you do that update.
Hey, yeah, I had the privilege of working very closely with the Space Force team, the 45th Space Wing, and through a lot of diligent work on their part and answering questions, we have received approval for the launch attempts that we have on the books. Really commend them for the extra effort to take a look. We needed to make sure that we provide the right level of public safety, and they're responsible for that, and they did a lot of work to help us get to where we are. So we have received approval for the launch attempts on the 27th and October the 2nd.
Thank you. Our next question is from Lauren Grush with Bloomberg.
So much. I'm wondering if you can go into the thinking of explaining why it's Plan A to hold the course for Tuesday. It just feels like there are plenty of things in the way with the potential of this hurricane. I'm still confused about the leaks being resolved. Feels like maybe this should be Plan B, and so I'm wondering what is lost by making the call to roll back now? Why push ahead?
Lauren, Tom, this is Tom. I'll start with the why we take it incrementally, and then I'll let Mike add some few words. You know, we've always done it this way. Even during the shuttle program, we would see adverse weather conditions form. There's some uncertainty in the direction and when it turns and if it turns, and the intensity and the timing. We'll meet again here as soon as we get another weather update, which will be at 5 o'clock today, and we'll meet with Charlie, Mike, and their team, and we'll take a look at that new data. And so we're just taking it a step at a time to see. When Mike mentioned earlier, we'll be making decisions actually fairly soon, and if we have to do one this evening, we will, and if we can wait till tomorrow, we will. And that's just normal standard practice for us.
And Tom, just to add to that, so, why is it Plan A? Well, the cryo test was a success. Right. So, in other words, we've got a launch vehicle that is ready to go, and so if we have an opportunity, we would like to launch it on Tuesday. Right now, we don't have a forecast that shows us with winds gusting higher than 74 knots coming across the Kennedy Space Center. So that's our Plan A. But we know we got to pay a lot of attention to it, and we know we got to get the decision right. So we are going to be again iteratively collecting that data and then collectively making that decision, and whether it's tonight or whether it's tomorrow, it's going to be data-based, and it's going to be to protect the hardware and to protect this program that we're a part of. But ideally, we're calling it Plan A because the cryo test was a success, and right now we don't have a forecast that violates our weather criteria.
Thanks. Our next question is from Jody Grelnick with CNBC.
Hi, thanks. Yeah, so I'm wondering if weather is the potential threat here, and that's really the only major concern. Is there any chance of earlying it up to like Monday to try to get ahead of that?
No, I can answer that. We don't have the ability to move it up a day. So our attempt opportunity will be the 27th. And that's why we really want to, incrementally look at the conditions of the weather. We'll look at it again today at 5 o'clock and make a decision. And there's different opportunities. If we are able to monitor the situation, we'll just have another conversation and we'll see where we're at. But to answer your specific question, the 27th would be the date that we would continue to target. If for whatever reason we're able to stay at the pad, but the weather doesn't look good on the 27th, then we would go to the October 2nd opportunity. But right now, we're mostly focused in on really kind of getting smarter about the weather. I'm not from Florida. Mike is, and so I'm from Washington, D.C., and the way we track weather in Washington, D.C. is we pick up the Washington Post in the morning, we see if it's going to rain this day. And so I actually am always amazed when I'm down here. These folks spend a lot of time here in Florida understanding weather patterns and predictions and directions, and there's different models that they follow, and there's just a lot of information to digest. It's still a tropical depression number 9. It's not a named storm. We really want to continue to try to get as much information as we can so we can make the best possible decision for the hardware, and that's why we're going to wait. We'll have another conversation at 5 today, and we're just kind of taking it a step at a time. But I don't know, Mike, I think that's probably, you've been in here for a long time, that's pretty much standard practice for how we handle these situations.
Yeah, and the other thing is that at this point on Friday, it would be pretty hard to get to that Monday launch with the team has been postured and moving towards Tuesday all along. So I know there were some other range factors and so forth, but at this point, given where we're at, it'd be really probably impossible to get to Monday.
Our next question is from Gina Sunseri with ABC News.
Yes, a couple of questions. What exactly are the weather constraints at a possible storm like this, the weather issues for staying at the launch pad? And then what's involved in taking it back to the VIB? I think you said earlier this week it would be 3 days.
So let's see, as far as staying at the pad, the wind, we want to see peak winds, less than 74 knots, and that's kind of the key requirement that we're tracking. Again, the rollback would be forecasted sustained winds less than 40, so that's something that we're paying attention to also. Not sure if I've got any more to add to that.
Yeah, Dr. Blevins, do you have any thoughts? No.
No, I think Mike's got it. We've got a robust design, but we want to protect the vehicle, and so we're just going to look at what the forecast is and the assurance, the percent likelihood of that forecast, and certainly we'll have to make a decision over the next 24 hours.
These vehicles, if you have a higher wind, less than the criteria, that we will keep it at the pad. That's a standard practice for the industry. It's not something you roll back just to roll back. It's we really will look at the weather conditions and make a good decision based on the information we have. And right now it's just too early. All we can tell you is what we know, which is we're going to take another look at 5 and we'll see what we got.
Next up is Jay Blackman, NBC News.
Sorry, I was involved in the earlier screening issue, so if this was answered, I apologize. If the weather precludes you from Tuesday, is there a date that you're looking at, and how would that also affect the Crew 5 launch?
Jake, actually my previous boss, Kathy Leaders, is in charge of the SOMD organization, and so my boss, Jim Free, and Kathy are in constant communications. We're going through all the different scenarios. This latest weather thing is new information for us, so we'll continue to talk back and forth and see where we're at. I think we really want to just take this next step to see where we're at, considering the condition of where we are with the vehicle. And so all I can tell you is we have a process that we've worked through. We look at different scenarios. It's an agency decision. We'll get the right people together within the agency to look at that. And then from us, we're really just trying to get to 5 o'clock today and see what the weather looks like this afternoon. So that's a great question. But I think right now we just want to focus in on where we are and the current situation. But I assure you, we've done this a lot. We've had previous conversations, and we'll make sure Jim and Kathy get together and we'll have that conversation once we get some more data. But we are protecting October 2nd, so it's certainly on the table as a planning date. But we'll also recheck with our folks over on Commercial Crew side.
Thank you. Our next question is from Eric Berger, Ars Technica.
Hi, good afternoon. Thanks for doing this. First of all, clarification, the 74 knots and 40 knots, those are gusts, not sustained winds, right? And then the second question, I guess, is maybe for Tom or John. The earliest reasonable arrival of tropical source winds at Kennedy Space Center is sunrise on Tuesday. That's from the National Hurricane Center. So you're saying you just need 3 days, right, to go from tanking and launch configuration to reaching the inside of the VAB? And, if that's on that timeline, your people would be exiting KSC in potentially tropical storm conditions. So I'm just wondering, if tropical storm force winds potentially are there by Tuesday morning, are you really leaving yourself enough time with 3 days from making the decision potentially tomorrow, mid-morning, late afternoon, or afternoon? Thanks.
Hey, this is John Blevins, Eric. On the first one, you know, there is a mixture. No, Mike got it right on the winds there. It is peak gust for the 74.1 at the pad, but it's sustained on the rollout, and those are knots, not miles an hour. And so, you know, the 74.1, just to let you know where that comes from, it comes from the 180-day winds that we record over decades here at the Cape, and it's referenced to a 60-foot high level. And so, no, Mike got that right earlier when he said 74.1 gusts, and then 40 knots sustained on the rollback. We're certified for those. And you know, you could actually slow down the vehicle and probably do more wind on the way back, but we don't want to do that analysis. We want to stay within the parameters that we've kind of set for that.
And then on the second part of the question, I mean, it's a delicate balance, right? I mean, earliest possible, perhaps is Tuesday. I think more likely, you know, if in fact this comes at us, the more likely is something along the lines of late Tuesday or Wednesday. We don't want to roll back if we don't have to, and so clearly the uncertainty of this storm makes this a difficult decision and makes the timing difficult as well. It may be that when we get to the 5 o'clock forecast tonight and we look at the forecast, that we feel it's the time to pull the trigger and to go ahead and put the rollback in motion. We hope it's not. We hope that that we're going to continue to feel like we've got some more time and that we can push the decision to Saturday morning. Obviously, the safety and health of our workforce is really important to us, and that's a factor in this decision that we make. So clearly, you know, it's not simple. We would like to stay out there, and we were hopeful that, you know, within this launch period, we're going to get another launch attempt, and that's why we're watching the weather so closely.
Our next question is from Emery Kelly, Florida Today.
Hey folks, thanks for doing this today. Just kind of maybe a question possibly for John. If a rollback is necessary, and it comes to that point, considering that the fueling test went well and everything hardware-wise is kind of in place and situated, does it make you, I guess, maybe nervous isn't the right word, but nervous to roll back, and then you got to roll back out again and reconnect everything and reseat everything? Does that introduce more points of possible hydrogen or fueling issues later on, or are you pretty confident that the fixes that you saw working this week will kind of hold through a rollback and rollout? Thanks.
Hey, Emery, John Blevins here. Yeah, good questions. You know, first of all, on the rollback, you know, we've talked a lot about rollback, and I think I've expressed my desire not to do too many rolls, you know, just because it is a broadband, a little bit of shaking. Vehicle certified for more rolls. If we need to do that, we're going to do that. There won't be any, you know, we're going to make a good technical decision on that based on the data, as Mike has said and Thomas said. But if we have to roll back, as far as, yes, we had a great tanking test. I don't think we should take anything away from that. It's another data point, certainly, if we roll back and forth and reconnect to the propellant lines. As far as the umbilical plate itself, where we replace the seal and everything, it stays in that position. You know, I'm not overly concerned. I don't have that data. Let's just be clear. It's still a machine, and you know, there are parameters that we're learning, and I don't think that the roll itself, looking at the frequency of that roll and look at the umbilical and its sensitivities, I don't think it'll have any effect. It's not on, until you asked, it wasn't a big issue. We have talked about it, but it's not something that's specifically on my radar per se as a concern on rollback or rollout. I think the main thing for me is that we did have a great test, that we did meet all our objectives, both primary and secondary, and we understand how that seal works. And I think we, you know, that is the reasons that we were having the issue, not anything from rollout or rollback. But it's a good question, and certainly if we have to roll out and roll back, there'll be some things that we do change, just some life-limited items that will be coming up in that case. But I'm not concerned about the leak with the roll per se. But good question, Henry. Thank you.
Yeah, this is Tom. Just to add to John's thing, you know, if we do go back to the VAB, We will take that opportunity. We got to do some battery charging. We'll retest the FTS system. We'll do some stuff like that. So
Replace it.
it will replace the battery on it. So we have some known things that we will do if we go back into the VAB. And so that's just to be clear, that's what we would do.
Okay, thanks. Our next question is from Emily Speck with Fox Weather.
Hey there. My question is for John or maybe Mike. Is there any scenario where it's better to leave SLS at the pad, like even through a tropical storm and a hurricane? You're talking about 74 knots. Like what is the max that you would potentially want to do that for?
Hey, Emily, that's a really good question. Actually, we're in the middle of conversations about what the best thing to do for the rocket is and hitting a launch opportunity and all of those things, both technical and programmatic, and balancing those. We do have a certified design with factors of safety to those peak gusts at the 60-foot level, and you probably know as well as anybody how that's generated. We have a conservative parabolic profile where all of the 180-day winds fall within that parabolic profile that we apply all the way up the vehicle. So those aren't just 74.1 knots at the 60-foot level. They're very high. I'd have to look it up to see what they are at the top of the vehicle when we evaluate that, and we're certified with factors of safety to do that. I think, and of course, that's primary loads. Your risk could be other things that might be moving around in a storm like that. And so if we actually experience a true hurricane, it'd be my recommendation, that we consider rolling back. Usually the footprint of those things isn't as wide, for those high winds. And so I think really this forecast is really very important to us that we're going to be trying to get more detail on over the next 12 to 24 hours. But ultimately, we have a pretty robust vehicle, and we'll just have to keep looking at that forecast to see if we fall within our certified parameters. Mike?
Yeah, hey, Emily, the first thing I would say is maybe you can help us out with this. We're really looking for that forecast. It's going to tell us.
Very online.
Going to tell us how.
Than we do. It was just we're going to get a really good, highly technical forecast at 5 o'clock. So we'll
and kind of just kidding, but what. And I think everybody recognizes that the forecast did change from Wednesday to Thursday to Friday, and so when we woke up this morning and the tracks looked worse than they had the previous 2 days, it really caused us to start to take a long, hard look at exactly what the right decision is, and that's what we're trying to do today. Hopefully, we have seen some trending of the storm, and you know it better than I do, but we've seen some trending of it moving west to east. So, a lot of the models early on showed us going into the Gulf, and they were fairly disparate. We've seen over the past 2 days it moved further to the east. And again, as you know better than I know, until that storm is formed, until we really know where that center is, until we understand the timing of that trough, there's an uncertainty. If it continues to trend to the east, and it curves, and basically, we stay on the left side of the storm, and it cuts through lower on South Florida, we're going to be in a lot better position. And so, if you were tracking stocks or if you're tracking storms, you've seen this move to the east a couple days in a row, and so maybe we'll see some more of that over the next several hours. And again, very dependent on the forecast that we get at 11, which I haven't seen yet, and the thing that we'll get at 5 o'clock, and we'll make the best risk-informed decision, like John Blevins said, based on technical, based on programmatic, and really, at the end of the day, we know we've got to protect this incredibly valuable asset, and we'll do that.
Our next question.
Yeah, and I apologize. I forgot. We've also got Mark Berger on the line. He's not sitting in the room with us, so I should have let him weigh in on that one. My apologies, Mark.
No worries at all, but I think you hit the nail right on the head with that. There's still a lot of uncertainty, and as you mentioned, the track has pushed a little bit farther to the east, so while it is a threat to be watched, certainly, and watched closely, it's one also that we can manage as well.
Our next question is from Chris Gebhardt, NASA Spaceflight.
Hi, yeah, I'm curious from the dual ops here of progressing down to rollback while also preserving and progressing the ops for launch on Tuesday. I'm curious, there was a specific umbilical in the shuttle program that had to be pulled, which would basically break and sever the connections with the ground. Is there a corresponding, is there a corresponding cable, a corresponding bundle that, like, once you go beyond that, it's basically like you've taken the vehicle off the pad and you have to redo all of the test connections? What's the equivalent point for that for SLS that you really wouldn't want to go past until you make the decision whether or not to roll? And on the 8-inch quick disconnect, again, I don't think I actually caught the answer to Bill's question, that the SEALs did the exact opposite of what they were supposed to at the beginning. The PAO officer called it a head scratcher, but then they started working. So can you sort of touch on how that is possible? And since you saw varying behavior with them, what is it that gives you confidence going into Tuesday that they're not going to leak in some other new way?
Hey, Chris, this is Brad McKenna. I'll try to answer the first one. I think you were talking on shuttle, the LOX and LH2 disconnect towers were connected to the mobile launcher for both commodities. So when you rolled off the pad, you disconnected there. So once everything else stayed connected when you rolled back to the VB. So once you did that and rolled back out, you would have to go ahead and sample the G and 2 helium commodities and then go ahead and redo dew points and things like that before you reconnected. And that took time, as well as do all the electrical connections and umbilicals and things like that. So it took basically reperform your pad validations, which was a day and a half or so of work. So anytime once you disconnected and rolled back to the VB, there was a amount of work you would do there. And as far as the second question on 8-inch QD, the leak signature we saw the second time was different than the first. So totally different signatures. It was also, again, manageable by the way that we controlled the loading. So again, I'm not sure if it was who asked the question earlier. No, we have requirements and specifications and launch commit criteria and things, and that we live by on all these things. So rarely do you get a pristine, perfect system that has from a fluid standpoint, that has no leakage. So throughout the shuttle program, again, I go back on my history, on LH2 systems, we had leakage pretty much every single mission, and you never heard about it because it never violated constraints and never made the headlines. But we'd have 500 parts per million or 1,000 parts per million, and some weren't reported because they never exceeded the limit to report, and some were reported and we took non-conformances but never exceeded safety plans and things like that. So we'll monitor the system, and if it exceeds requirements, we'll report them and respond accordingly. But John, I don't know if you want to add anything to that, but.
No, Brad, I don't have anything to add. Good detail.
I guess this is Mike Bolger. The one other part of the question that you asked about, again, were, what are the things that you can do to get ready? And just a couple things kind of come to mind. We asked our crawler team, hey, let's go make sure we're ready to go. Let's start thinking about when we got to position that crawler, when we want to roll it out towards the launch pad. So they're in the process of doing that. We're taking a look at the condition of the crawler way, making sure it's all ready to go. And so the team is looking at that. And the other things we're talking about are, can we do hurricane preps across other facilities around Kennedy, get those done early and kind of behind us before you might normally even get into them based on the HRCON conditions, so that we can free up as many resources as possible for the actual rollback opportunity, and basically compress that timeline and get it done even faster than we otherwise might have. So we are taking a look at things we can do to kind of get ahead of the game, if you will.
Okay, we're going to take 2 more questions and then wrap up. Our next will be from Marcia Smith with Space Policy Online.
Thanks so much. I was wondering if Dr. Blevins could talk a bit more about how it is that the Space Force was convinced to extend the battery limit. It was a 20-day limit, and you got it extended to 25, and now it's been extended for basically 3 or 4 weeks past that. So what was it that set the 20-day limit, and how were you able to convince the Space Force that, in fact, it's good for many weeks past that? And is this a precedent now? Does this mean that for future launches that use that battery, that you no longer will have the 20-day limit?
You know, Marcia, those are kind of insightful questions. Let me just say the Space Force owns the mission and the analysis, and we do the analysis they request as well as a lot that they do. And so they've done that analysis, and they have confidence in our system for this time. I don't want to go into any details because it's just not pertinent here. You know, to give those kind of details and you know, would be silly because there's just too many parameters that they look at for anybody to take that information and try to correlate it to anything that makes sense to them. So I'll just say that they've worked with us all along. This is not the first time that we've been working with them. We worked not just during the shuttle program, but on this program for years. So they're involved in evaluating our design, our qualification batteries, and the testing that we do. They sit on console with us, and so they're part of our team. And so they have an incredible mission, and they do a good job at it. And I'm really glad that we had enough information to provide the public safety assurance that they get to grade. And so that's all I've got to say about the FTS.
Okay, thanks, John. And our last question is from Stephen Young with Spaceflight Now.
Hello, Stephen Young with Spaceflight Now. Just to follow up on a few things, and sorry if I might have missed the answers to these during the technical problems. With the FTS certification, what happens if you're not off the ground by the 2nd of October? And for rollback, if you had to do that, do you need to offload the hydrazine for the HPUs on the boosters? And if you do roll back, are we looking at November for the next launch opportunity?
Okay, I'm watching Mike Bolger as I speak right now. Let me take it from the back question to the front question. This is Tom. Our pre-planned approach for hurricane rollback, we do not desurface the HPUs. There's 4 gallons of hydrazine in each one of the power units that we use to power the hydraulics and the boosters, and those will stay in the vehicle as we roll back into the VAB. In terms of our ability looking forward, I don't think we know yet in terms of what our schedule would be looking forward. Like I said, we've got to sort through. We're going to do the FTS battery change out. We're going to do some other battery charging activities. So we'll lay that out when we make a decision to actually roll back into the VAB. And so after that, we'll have a better idea of what our trip back to the pad would look like and what kind of dates we would target for that. Right now, we're literally mostly focused on the current weather reports. We have a lot, the agency has, and the folks here have a lot of practice on really working through those forecasts, working closely with our weather office, and then if we have to move up a decision because of a change, we'll move up the decision. If we have a little bit more time for a decision, we'll take a little more time for the decision. But this is actually fairly standard. I mean, I did the shuttle program for a long time, so I've watched this for myself. I watched it quite a while, and we're following the normal procedures, and we'll absolutely make the right call with this vehicle. And we feel that this afternoon we'll have another conversation on that. We're in constant communication with the folks. Mike and Charlie and team are in constant communication, and we just, if I wish we were better at predicting weather absolutely 5 days in advance, and if I did, I would pretty much quit this job and go work for the Weather Bureau, but there's still some uncertainties in the forecast, and therefore we want to make sure we have an ability to get a little bit better definition, and then when we get that definition, we'll make the right call. I don't think Mike, have any, that's it.
Okay, that's all we have time for today. We did have some technical issues with our live stream for those not initially dialed in. So we will be posting a full recording of this teleconference as soon as we can on our Artemis blog. You can find that at blogs.nasa.gov/Artemis. And we will also be posting additional updates there. And with that, I'd like to thank everyone for joining us.